Section 5.3, example 2, finding the x-intercepts of a polynomial function by factoring. So find the x-intercepts of f of x is equal to x to the power 6 minus 3x to the power 4 plus 2x squared. All right, so I noticed the very first thing, each of these have at least an x squared, so we could factor that part out. So factoring out an x squared. If we were to divide this by our x squared, we're ending up with x to the power 4. If we divide this by our x squared, we're left with negative 3x squared. And if we divide this by our x squared, the x squareds divide out and we're just left with that 2. And actually, before we start, I got a little excited and just started factoring. So they did tell us by factoring, but find the x-intercepts. So our x-intercepts happen when y is equal to 0. So our goal here is to set our function equal to 0. So factoring is the only way that we're going to actually solve these unless we have another form of like identifying solutions. But right now, the only thing we know how to do is factor. So let's go ahead and factor. All right, so now this isn't quadratic, but it is quadratic in form, which means we could force it to be quadratic. Like we could look at this as w squared, where w is equal to x squared. So it's quadratic in form. So with that, we could still factor it as if it were quadratic. So we're looking for 2 values here. And actually, let's do some factoring by grouping just to kind of show we know how to do that still. So we're looking for 2 numbers that multiply to 2 but add to negative 3. So factors of 2 are 1 times 2, and there really isn't anything else other than that. 1 times 2 gives us 2, but it gives us a positive 3. If we make both of these negative, we have what we're looking for. So negative 1 times negative 2 gives us a positive 2. Negative 1 minus 2 gives us negative 3. So now we're going to rewrite this expression up here with a 1 and 2 instead of that 3. X to the power 4 minus x squared minus 2x squared plus 2. And then we're going to group the first 2 terms together, grouping the second 2 terms together, making sure that there's a plus in the middle, and factor out as much as you can from each of those parts. Here we could factor out at most an x squared, leaving us with x squared minus 1. Plus over here, we could factor out a negative 2, leaving us with x squared minus 1. And since both of these have that x squared minus 1 in common, we could factor that out, leaving us with that x squared minus 1 times x squared minus 2. And it looks like we could factor this part one more time. X squared, we have x plus 1, x minus 1. We could technically factor this, but it just looks a little bit uglier. It'll be easier if we just set it equal to 0. X squared minus 2. And now from here, what we're looking for is our function. So our function equal to 0. So what values make our function equal to 0? And we could separate this using our 0 product properties. So we have this that we're solving for now. So this whole part over here on the right side is equal to 0 when x squared is equal to 0, also when x plus 1 is equal to 0, also when x minus 1 is equal to 0, and also when x squared minus 2 is equal to 0. And let's figure out where this function is equal to 0. So here we could take the square root of both sides. We have x equals 0. That's one solution. Add 1 to both sides, or actually subtract 1. From both sides, we have x is equal to -1. Add 1 to both sides, x is equal to +1. Plus 2, we have x squared is equal to 2. And take the square root. When we take the square root of a square number, we have to give it the option of it being positive or negative. So we have two solutions there. So let's see, we have 1, 2, 3, 4, 5 different solutions here. So our zeros of this function is what we call these. Our x-intercept are when x is equal to 0. So we have 0, 0. For this one, we have -1, 0. For this one, we have +1, 0. For this one, we have two solutions. We have the square root of 2, 0. And lastly, we have -√2, 0. So those are all of our x-intercepts. If you have any questions, please feel free to ask. Otherwise, bye.